My name is Rob Harmon. I am the director of the MEETS Coalition, and I am here to talk to you about MEETS for utilities and how we believe it can help accomplish deep energy efficiency while maintaining healthy and stable utilities. The presentation should take about 20 minutes, and then I'm going to leave the rest of it for Q&A. So our premise about deep energy efficiency is that it is currently not scalable. And it's not scalable for a couple of really important reasons. One is that it undermines the utility business model. That's what this presentation is addressing. And the other is that there's a set of split incentives on the real estate side for building owners that destroy the economics locally. So let's get to the utility economics piece of this. This is a graph of the California power mix in 2011. I'm sure there's another one that's more recent, but this tells the story. And what this graphic shows is the portion of the California energy mix that was met by energy efficiency. Many of us would think of that as very good news and would want that red box to get larger. This is a similar graph of the Pacific Northwest with load growth and the portion of that growth and the portion of load that's met with energy efficiency. So again, many people would applaud that as a great accomplishment. Of course, in the utility C-suites, that energy efficiency represents utility red ink. Utilities earn on investments like generation. So traditional EE is viewed as negative sales, as lost revenue, and as lost investment opportunity. This is a graphic from the Edison Electric Institute's report a few years back that is essentially on the utilities' concerns about the death spiral around energy efficiency and distributed generation, essentially anything that happens behind the meter. And I think this quote says it all. It could have a major impact on realized equity returns, required investor returns, and credit quality. So these aren't the concerns generally in the energy efficiency offices of utilities, where people are directed to capture energy efficiency up to the utility's regulatory requirement. But in the C-suite, utility bond ratings are an essential part of what is important to management of the utility. The graphic on the right demonstrates that back in the 70s, most electric utilities bond ratings were AA, AAA, and single A. If you look at 2011, what you'll see is that the majority of them are now below A. That's a very serious concern for CEOs of utilities. And a portion of this degradation of their credit ratings is from Wall Street concerns around all the stuff that's happening behind the meter and its impact on unit sales. So the result of that is, and we see this everywhere, of course, is that utilities will resist energy efficiency, and particularly at scale. The fact of the matter is that they can't allow it to scale without changes to energy efficiency policy. So that's not a values choice. That's a pure economic and business model choice. It is simply a fact that the things that happen behind the meter that reduce sales create significant challenges for utility balance sheets. So that's utility economics, and I'll get to this, how we believe MEETS addresses those momentarily, but I do want to give you very quickly the economics from the building owner perspective. So most of you already know this, but let me summarize it. Building owners in general with energy efficiency are asked to invest. The tenants keep the savings. These are non-owner occupied buildings I'm mentioning here. And the results are the results we see, which is that you see short-term paybacks if you see any activity at all. This is the classic split incentive problem. I'm going to show it to you graphically here. If you think about the commissioning of an energy efficiency project, and on your vertical axis there are all of the savings. So regardless of the depth of the retrofit, just think about that as 100% of the savings. And the vertical axis is time. So you would expect, if energy efficiency measures were installed and maintained, that the available savings would be consistent over time. in the same way that you'd expect that from a wind farm. You install it, you commission it, you maintain it, and you get the energy output. So you can think of all of that savings in energy units, or more practically, you can think about it as dollars. So think about the investor's perspective. So they're asked to invest behind an energy efficiency retrofit, and these are the economic benefits available to them in dollars. Of course, we know that this isn't what happens. This green bar is what actually happens. Nearly every utility and regulator in the country looks at a graph like this and says, these energy efficiency measures degrade over time. And it's naturally what happens if you don't pay for performance. The measures are not maintained and they degrade over time. So that's what you would see in a perfectly functioning owner-occupied building, where people simply forget to maintain the measures because they have other things to do. But if you're in a non-owner occupied building and the tenants get the savings, the actual available returns for the investor are this red line. They may get a bump in the first year from the utility incentives, which tend to make a modest contribution toward upgrades. But the cash flows available to the investor after those incentives are paid are zero, because all of the money flows to the tenants. So they may be able to put some kind of relationship together with the building owner, or they may not. But this is what investors look at when they see the idea of energy efficiency in non-owner occupied buildings. In owner occupied buildings, this orange graph is residential. The available savings to a homeowner is based on the length of time the owner will own that particular home. In the United States, the average home ownership is 5 years. So if you approach a homeowner, they have lived in that building already for 2.5 years on average. And that's why the rational economic choice is the one we see, which is that homeowners ask for paybacks under 2.5 years. And we see that all over the place. That's a rational economic choice. On the commercial building side, the average ownership is a little less than 9 years. And not surprisingly, the paybacks that you see in owner-occupied commercial buildings are 4.6 years and below, when you see them at all. So those are rational economic decisions. That is simply about the recognition of either the split incentive between the building owner and tenants, or the rational economic decision about the split incentive between the current owner of the structure and the future owner of the structure. If I can't get my money back while I own the building, I don't want to pay for the benefits that will happen for the next owner, because I'm not sure that I can recoup them. So those are rational economic choices, and these are the reasons we see these short-term paybacks. And those short-term paybacks obviously don't support the kind of depth in buildings that many of us believe we need in order to meet our energy and our climate goals. MEETS was designed to solve those problems. It was designed to harness the economic benefits of energy efficiency to the same degree that we harness the economic benefits of a wind farm or a solar array or a natural gas plant, where all of the financial benefits that are available for the length of the life of the project are made available to the participants in the transaction. So I'm going to show you how that works. And how that addresses both the building owner split incentive problem and the utility economic problem. So the basic solution to this problem, in my view, is to treat energy efficiency the same way we treat generation, not just philosophically, which I think we're already made a lot of progress on, but actually in terms of the way we think about it and the way we transact on it. There are a couple steps in that process. One is you need to meter it efficiently and accurately over long periods of time. And the second is you then need to buy and sell it in the same way we buy and sell generation. And that's what MEETS was designed to do. And I will show you now how that works. This is unfortunately a slightly fuzzy graphic of the meter currently operating at the Bullitt Center in Seattle, where MEETS has been implemented. So what this graphic shows is a baseline. This says derived from prior use, but in the Bullitt Center's case, it was derived from the prior use of existing buildings built to the same or similar code. So with a new building, obviously you need a code baseline. I don't want to get into the machinations of that. We can talk about that at other times if you'd like to. In an existing building, that baseline is the existing condition prior to the retrofit. So that's a derived baseline. You calibrate and normalize that baseline moving forward, and we could call that the native load of the building. Other people call it a dynamic baseline, a calibrated baseline, a normalized baseline. We hear this a lot. There are many terms for this, but it is not a static baseline. That's the essential thing. It is dynamic. That green line at the bottom is the actual energy consumption for the building, and the efficiency, the metered energy efficiency, is the difference between the native load or the calibrated baseline or normalized baseline and the supplied energy to the building. So that purple shaded area is the metered energy efficiency. The meter at Bullitt was accurate within less than 1% in its first year of operation. So we're quite confident in the ability to maintain dynamic baselines over time. That meter is transparent and auditable. Nothing is in a black box. This is the energy efficiency statement for the Bullitt Center. So what you see here are these three ovals. The one on the left is the adjusted baseline. That was that top line. So again, that's dynamically adjusted. The utility meter is the middle. You subtract the utility meter from the adjusted baseline, and what you get is the kilowatt hour yield from the energy efficiency in units. So you have these resulting units of energy efficiency monthly, and once you have the meter reading, you can transact. The meter here is fractal, both in terms of the size of, it can do multiple buildings, it can do one building, it could do individual floors, but even more importantly, it is fractal in terms of time. So if you give it 15-minute data, it can give you output every 15 minutes. If you give it monthly data, it will give you monthly data. Whatever, it depends on how much smart metering you have and what level of granularity you want. But it functions perfectly well in monthly data. That's what it's doing at Bullitt. So again, once you have this kilowatt hour reading, you're able to transact. So that's where MEETS comes in. So we've now got our meter reading, and what do we do? How do we treat this like generation once we have a meter read? So one of the essential pieces here to remember is that MEETS is not an incentive. It's simply a structure. It's the way the parties in the transaction interact with each other, how their contracts work, and who pays whom for what benefit and who does what. So I'm going to show you this. I'm going to talk about this in words, and then I'm going to show you this graphically. So MEETS was designed to use the savings value that's currently given away to the tenants. That's the split incentive. So we're designing this around eliminating the split incentive and using those cash flows to get depth in the building. That savings is often worth 4 to 20 times the incentive value. In MEETS, as I said, the energy efficiency is metered against this dynamic baseline. Here's the tricky part. It's then sold, as any other generation is, to the utility, not to the building owner. And it's sold to the utility under a long-term power purchase agreement, in the same way that all other energy is sold, except obviously energy in short-term markets. But it's sold under a PPA just like it would be from a gas plant or a wind farm or a solar array. This is the other tricky part. The utility then bills the building for the energy efficiency in those energy units at retail rates, and that's what eliminates the split incentive. The building's paying for delivered energy efficiency on its energy bill at retail rates. Now, this is a really key piece. So in some ways, it's like on-bill finance because the charges are appearing on the energy bill, but it's not a finance charge. It's an energy charge for the metered energy efficiency. If the developer doesn't deliver that energy efficiency, the building does not pay for that on its energy bill because the energy efficiency wasn't delivered. So it's true pay for performance. I'll show you that graphically. So we'll start with the building. MEETS uses what we call an energy tenant for some reasons that I'll get into, but you can think about this as the developer or the ESCO. Any party can play this role. I've separated it out as a separate party in this graphic to make the party and the relationships clear. So you can think of the energy tenant as an ESCO if that's easier for you. They have a long-term rental agreement to harvest and sell metered energy efficiency. And they then use, under that agreement, they pay for and maintain the improvements in the building. Because they are a tenant in the building, they pay rent to the building owner for the use of the building to harvest energy efficiency. So the building owner has a more comfortable and valuable building and receives rent. The building owner agrees to pay the utility bill, including the metered energy efficiency that's on the utility bill. The tenants have a more comfortable and productive building and simply pay their share of the utility bills, including the metered energy efficiency, in the same way they do now. The landlord's responsible for managing the relationships with the tenants and how the tenants pay for all kinds of things in the building, the snow plowing, the window washing, the property taxes, and either their energy bills if they are not individually metered, or their share of the common area bill if they happen to be individually metered for their own energy use. With meets, if there's a common area meter, that's where the charges are put, and the landlord simply distributes them to the tenants in the same way they distribute the common area energy bill. So for the tenants, there are no changes at all. They pay the same thing they've paid before, and they have a much more productive and healthy building for free. For the utility, getting back to the utility economics, they maintain their unit sales because they are now selling energy efficiency units as well as generated energy units. So their gross revenues are maintained and their unit sales are maintained. The utility reads the dynamic baseline meter, and they pay for the energy efficiency read by that meter. Again, it's a transparent, auditable meter. And they pay for that. They pay the energy tenant for that metered energy efficiency through a long-term PPA. That cash flow is what the energy tenant uses to pay the investor for the capital that was invested in the building. Any party can play the investor role. I have building owners who want to play that role. Energy tenants themselves can play that role. I can see a world where utilities can play that role and earn a regulated rate of return on capital. That, of course, is a regulatory issue to address, but I see no reason technically why utility capital shouldn't be allowed to be invested in energy efficiency in this sort of transaction structure. The benefits for the utility are that the MEETS agreement should be structured in a way that is net present value positive for the utility and its ratepayers. So the utility would be paying less under the PPA to the energy tenant than they're receiving from the building owner for the metered energy efficiency. So unlike net metering, the MEETS agreement should be NPV positive for the utility. As I said, there are no lost unit sales or gross revenue losses. There are no incentives necessary in this transaction structure, so you don't need to use non-participating ratepayer money. The utilities are paying only for delivered units. There is nothing deemed in this transaction structure. And as I said, I believe there's a rate-basable earnings opportunity for utilities. A couple questions that have come up. Will utilities need a new tariff? The answer to that will depend, of course, on your regulator. We believe that if we all agree that energy efficiency should be treated like energy and it is metered in a way that is open and transparent and accurate, that it should be sold at retail rates just like any other energy unit. How regulators choose to do that, of course, will be determined at a jurisdictional level. Many regulators will allow experimentation for pilots, and we think that's a good way to get started. We suggest doing a multi-building pilot and to bound the risk associated with that pilot by the size of the pilot in energy units or square footage or however you'd like to define that, but not by the term of the pilot. Because if you limit the term, you will limit the depth and you won't fully be testing the possibilities with MEETS. Another question that's come up is, doesn't decoupling solve this problem for utilities? And the short answer is no. What decoupling does is to allow utilities to recover revenue from lost unit sales more quickly, whether those lost unit sales come from weather issues or whether they come from energy efficiency or DG or whatever the source. Decoupling allows them to recover those lost revenues more quickly. But what decoupling doesn't do is to solve the lost unit problem, which happens whenever you do stuff behind the meter in transaction structures other than MEETS. When you have fewer units in the system, that obviously increases the cost of the remaining units in the system. And that's what will drive up rates for those remaining units in the system. MEETS doesn't reduce unit sales or gross revenues, and hence really does address this problem that decoupling doesn't get at. So this is my last slide, and then we're going to get into the Q&A. So again, for the utility, it's potentially a new load management resource. You can make it location specific, and it's reliable because it's metered. You know what you're getting. You only pay for the units that you receive. It's rate baseable, or should be. Again, we have no gross revenue loss, and we have no unit sale loss. For building owners, they have this new long-term tenant and a new revenue stream from the rent. That increases the building's value, and it frees up the building owner's capital because they don't need to use their own capital. And it keeps the building owner out of the energy business if they don't want to be in the energy business. Importantly, I think for the investors, this is financing based on a utility PPA. Financing, people do that all the time. You have a very strong counterparty because the PPA counterparty is the utility. You have lower end-rated payment risk associated with that PPA. These are extremely well understood instruments in the market, and you can scale this through aggregation of multiple buildings. I won't go through the societal benefits, but they're similar to what you would get from energy efficiency, except that you're doing them at depth. That is the end of the formal part of this. I've left my contact information here on the screen. I'll leave it there for a few minutes. My guess is we'll go back to a graph or two in the PowerPoint as people ask questions. So why don't people ask away? How can I be helpful to you in figuring this out for yourselves?
Yeah, hey, Rob. This is Ian from NG Services. Great presentation, by the way. It's very helpful. I was thinking of the stacked graph you showed that shows the degradation of savings over time and the split incentive. I really like that visual. How should any entity that's looking to play the energy tenant role think about that, given that they would be responsible for maintaining performance over time, and that equipment, new efficient equipment even, degrades over time and must be replaced, and it may need to be replaced before the end of the PPA term. How should utilities and energy tenants think about that, and whose burden it is to maintain the equipment over time? Just could you help us think about that a little bit?
Absolutely. When I get questions about how should people think about MEETs, I always ask them to not think about it the way they would think about any other energy efficiency transaction, but to think about it the way they would think about a wind farm. So when a developer builds a wind farm and they sign a PPA with the utility, they presume that there will be some point where they will need to start replacing inverters. They presume that one of the turbines will be hit by lightning at some point, or whatever the issues are going to be at that wind farm. They presume that they will have to take care of bearings and other things that are classic O&M at a wind farm. This is the same. So when the energy tenants build their pro formas, they will build into those pro formas the ongoing O&M of these measures. For major capital improvements that the energy savings may not pay for instance, if the life of the chillers is shorter than the life of the PPA, they will build into the chiller replacement budget some agreement with the landlord, because the landlord would has to provide air conditioning to their tenants, and hence the landlord will need to replace that equipment anyway. So as in any sort of ESCO agreement or any other building maintenance agreement, when there are major capital improvements that are required not necessarily for energy purposes, but for the maintenance of the ongoing maintenance and performance of the building, those agreements, those portions of the agreements would need to be negotiated with the building owner. That's done all the time. But for standard O&M stuff, you gotta maintain the weather stripping on the doors. You got to make sure that all the windows that are supposed to operate. You got to make sure the lights work. That's all on the energy tenant to put into their pro formas as they negotiate with the building owner for how much rent they're going to pay when they negotiate with the utility for the proper price of the PPA. That's all in that pro forma. Does that answer your question, Ian?
Yeah, that's really helpful. Thanks.
Sure.
Hi, this is Matt Smith with SDG&E, and I was curious on the, can you scroll ahead to kind of your circular chart with the payments essentially. So
This one here?
yeah, so is the building owner paying a utility bill? You're saying including metered energy efficiency. So are they paying the actual consumption of the building plus a extra fees based on the energy efficiency that you're claiming has been delivered in the building?
Yes. The way we think about that, and I think the way this should function at scale, is that dynamic baseline meter in the upper right has the functionality to perform on the system like any other smart meter. It can take readings from the utility and it can send readings back to the utility using standard smart meter interfaces. So it should, at scale, show up at the utility and on the utility bill to the building owner as simply another meter read billed at retail.
So the utility billing system would just operate off of this secondary meter rather than their read from the building itself?
No, it would operate off of both meters because the information coming back from the dynamic baseline meter
Is
is
just
the
the energy efficiency?
Yeah, it can send you the rest, but you already have the rest, and in fact, it got its
Right.
it got its actual energy use read from you guys, right? From the utility, right? So you already have that data. So the way I think about this is ideally it's just like a second meter on the side of the building that says, here's your energy efficiency consumption, right? And then it should fit smoothly into the billing system. Now, I don't want to be Pollyanna about that.
Yeah, that's what I was going to get at.
Right. Getting that done is a different issue, right? And whether in a pilot you want to actually go through that or not, or whether what you want to do is simply put it on the building as a separate charge that people can understand and audit if they want to, that of course is going to be utility specific. It's going to be regulator specific, right? Everybody's going to, I don't want to pretend there's some sweeping answer to this that everybody's going to immediately adopt, right? But the important thing here is it's a third-party meter read, so you don't have the problem where the ESCO is telling you how much savings happened in the building, and that it's all done with transparent algorithms. Everybody can see them, and anybody can audit that if they don't like it. So what the meter functions as is the settlement mechanism that everybody agreed would be the basis for settling the transaction. And then if people want to poke at it, they're welcome to. But the meter read is the meter read in the same way that the meter read on the side of the building is a meter read on the side of the building. If you want to audit that, you can go ahead and do that too, right?
Mm-hmm.
If somebody doesn't like their Itron reading, they can talk to you about that. They can talk to you about this one too, but it's just the meter read. Okay. Does that make sense? Is that helpful?
Yeah, that does. Thanks.
Sure. Who else?
Rob, sorry, this is Ian again. I'm kind of building off my last question. I think if I'm a utility and I'm thinking from sort of the old deemed incentive model, I'm thinking about effective useful life of measures. And I'm wondering from the utility seat, why should I pay beyond the useful life of measures that are being installed in the building once they fail, say a 10-year lifespan of an LED, for example?
Because the energy tenant's responsible for replacing those. And if they don't replace them and they fail, then the energy efficiency in the building fails and you don't pay because you only pay for what you get. So if the energy tenant were making decisions in the building to not replace efficient lighting with more efficient lighting or with efficient lighting, the building's energy bill would go up and the amount that's being paid under the PPA would go down. The utility only pays for energy efficiency they actually receive. So as measures fail, if the energy tenant doesn't replace them and improve on them, then the payments from the utility go down. So the utility is perfectly protected against system failure because they don't pay if it doesn't happen. If the energy efficiency is not there, the utility doesn't pay, and neither does the building. The risk is squarely where it's supposed to be, which is on the energy tenant to perform in the same way that it is on a wind farm. So again, another way to answer your question, Ian, is if the wind turbine if the wind farm fails, the utility is not paying for the output that was supposed to be there. If the wind turbine isn't replaced or repaired, the value of the PPA falls for the developer, right?
Yeah.
I was following on as Matt Smith again. So
Yeah.
the traditionally, at least with utility programs, we're paying a fraction of the price for a kilowatt hour of energy efficiency as compared to the actual rate that a customer would pay for that same kilowatt hour.
Sure.
So for this circle of investment and payments and so forth, the energy tenant, like the way that they're going to contract the payment for that improvement is presumably on the energy savings at the expected cost of kilowatt hours from the rate standpoint, but the payment they're going to get from the utility is likely going to be less than that kilowatt hour price. So you're going to extend your paybacks to much longer periods for things that would otherwise potentially be relatively short paybacks.
Let me
Does that make sense?
Yeah, I think so. So let me tell you the way I think about the cash flow associated with that. And I may answer your question in a bit of a roundabout way. And the most important thing is, if I don't answer your question, let's work on it a second time.
I ask it in a very roundabout way. So
it's okay. It's a roundabout graph. So here's the way I think about it. From the utility perspective, in a normal transaction, let's just say, to make the math easy, let's say retail rates are 10 cents a kilowatt hour, right? Normally what happens from the utility perspective in the normal energy efficiency is, when it happens on the customer side of the meter, the utility immediately loses 10 cents a kilowatt hour of retail revenue, and the utility pays out an incentive that's net present valued, but is probably worth about 2.5 cents per delivered kilowatt hour. So you might NPV those for a 5-year measure or something, and pay out the total savings all at once for your LED light bulb or whatever. But those calculations are all done based on some sort of value the utility and its regulators have presumed for the value of a delivered kilowatt hour on the system. So when you talk to utility executives, when in a 10-cent retail market, they understand that the revenue impact for the utility of a delivered kilowatt hour is the 2.5 cents of per kilowatt hour payment plus the 10 cents of lost retail revenue. So the economic impact of that is 12.5 cents a kilowatt hour for the utility. And what they get is a free kilowatt hour out of that transaction. With meats, what the energy tenant is saying is, we don't want your 2.5 cents kilowatt hour in a standard transaction. People are going to discuss that and with the utilities and potentially argue about it or not. But in a straight up meats transaction, the way we've envisioned it, there are no incentives. And what the utility is doing is taking a portion of that 10 cents of retail and paying it to the energy tenant. That's what allows you to get deep in the building. Let's say, for lack of argument, that you start that payment right at 10 cents even, but the escalator in the PPA is 2% instead of a retail escalator of 4 or whatever, right? One way or the other, the utility needs to become NPV positive, in my view. How NPV positive it is up to the utility and the regulator, right? But the essential thing here is that from the utility's perspective, they have not paid out 2.5 cents of ratepayer dollars, and they're NPV positive. Neither of those is true on the traditional energy efficiency side. And the utility still has the units in the system. So in every way, and it's metered, so you only pay what you get. So in every way, this transaction structure is economically superior for the utility than compared to traditional EE. For the energy tenant, you are right that there will be a payment to the energy tenant for some upgrades to the building that can be done for less than, in this case, let's say 10 cents kilowatt hour, just again to tell a story and make the math easy, right? But that's all going to be in the same way that there are some wind turbines at a wind farm that are more productive than others. All of that is going to be put into a total project pro forma, and all of that is going to be discussed with the building owner. And if the building owner believes that the returns are too high for the energy tenant, then the building owner is going to extract more rent, in which case a chunk of that revenue flows to the building owner, which is where it would flow in a traditional transaction where, well, it would flow to the tenants, right, in the form of savings. So the parties will work this out so that the returns, the proper returns, are shared with the proper parties. But in the same way, I'm not concerned about one particular turbine at the top of a hill with a 50% capacity factor that could be built for a PPA at 2 cents being too profitable for a wind farm. It will help pay for the turbine lower down the hill that has a 25% capacity factor that would need a PPA, above 4 cents in order to get that one to pay for itself. So it's a blended piece designed to get all of the energy efficiency, to harvest all of it in a single project or in a series of projects over time, depending on what's happening in the building. But the utility is better off immediately, and its ratepayers are better off immediately. The question of how much of the economic benefit that the building owner and its tenants are paying for will flow to the energy tenant and the investor, and how much will flow to the building owner, that's up to those parties to negotiate. The utility and its ratepayers are better off in all circumstances. So now the question is, have I actually answered your roundabout question with my roundabout answer?
I think so, to a degree. I think there's, I think the regulatory part of the conversation is going to play heavily into how that works in each area.
Sure. So
it's definitely reasonable from an economic standpoint. But
yeah,
we don't operate in a free market.
Right.
At least most places that
Right.
there are utilities aren't operating in a free market kind of scenario. So it'll be.
I think the really important thing to remember, though, is that one of the reasons we have been so rightly focused on the way we think about cost effectiveness is because traditionally energy efficiency is all funded. Well, all of it is funded in part with non-participating ratepayer dollars. So if you're using my aunt's systems benefits charges to pay for your uncle's building upgrade, regulators are rightly deeply concerned with how my aunt's money is being used to benefit your uncle. In this circumstance, the building is paying for its own upgrade on its own bill, and MEETS doesn't ask non-participating ratepayers to contribute to that. That's a radical departure in the world of energy efficiency and will require, I agree with you, some very significant head scratching from utilities and regulators about how to rethink what the definition of cost effective is if we're not using other people's money. And in fact, the utility ratepayers are coming out ahead. So I would encourage us all to have these conversations. I think as long as people really understand the economics of it, we will come to the proper decision. And that decision may be different in different places. Is that helpful?
Yeah, thank you.
Sure. Anybody else? All right, well, I will put up on the screen here at the very end, once again, my contact information. Feel free to email me or call me. So thank you for your time, and I hope to talk to you soon.